Let's talk about polyatomic ions. These are ions that are made up of more than one atom. What do they look like? How do we write Lewis structures? And how do we write chemical formulas that involve polyatomic ions like ammonium and sulfate, carbonate, nitrate? What is a polyatomic ion? It is a covalently bonded particle. The electrons are shared between the atoms of the polyatomic ion. It's just like a covalently bonded molecule, but it has an electric charge. It either has more or less electrons than we would imagine for a molecule, and therefore it has a charge. So, for example, the hydroxide ion has one electron more than O and H would together have ordinarily. Polyatomic ions are held together by strong covalent bonds, and except when electrons are gained and lost, as in an oxidation-reduction reaction involving the polyatomic ion, the atoms of the polyatomic ion do not separate. They stay together in chemical reactions. So, when calcium nitrate solution is added to sodium hydroxide solution, you get a precipitate. The precipitate is calcium hydroxide. The hydroxide does not come apart in this reaction. It stays together as an ion. Before the reaction, the hydroxide is in solution surrounded by water molecules. But after the reaction, the hydroxide, which is still bonded oxygen to hydrogen, the hydroxide is associated now with the calcium ion as a solid, and the water molecules don't have enough energy to break it up. That's why you get a precipitate. Remember, compounds with hydroxide ions are bases. Now, how do you write a Lewis structure for a polyatomic ion? Well, you have to know how many total electrons there are. You write a skeleton structure with a less electronegative atom in the middle. And you covalently bond that central atom to all the other atoms surrounding it. You complete octet shells of the surrounding atoms after adding or subtracting the electron charge on the ion. So you do the octets as well as you can once you've got all the electrons around all of the atoms. So let's do hydroxide. It's got 6 total electrons from oxygen. That's valence again, only the valence electrons. Hydrogen has 1 valence electron, and you also have an electron to spare, the negative charge on the ion. Oxygen, of course, will be bonded to hydrogen. The covalent bond between the central atom to hydrogen. We now have a complete hydrogen shell needed because we've got 2 electrons and 1 comes from the oxygen. And when we complete the central atom so that it has its other 5 electrons, then you have this, and then of course that last electron comes from the negative charge. So there's 8 electrons in all, and you saw them. So let's work out the sulfate ion structure, Lewis structure. Sulfate has a -2 charge. Total valence electrons, well, oxygen has 6 each, there's 4 of them, giving us 24. Sulfur also has 6 valence electrons, so we have a total of 32 electrons when we add the 2 from the -2 charge. So we have to distribute those 32 electrons around the SO4. Well, we set up the skeleton structure. Sulfur is in the middle because it's less electronegative than oxygen. We put complete shells around the outside atoms, and we see 8, 8, 8, and 8. The oxygen have each one has a complete octet, but since there's a bond between the sulfur and the oxygens, the sulfur also has a complete octet, and so this is a complete Lewis structure. We've done it. Now, how do you write formulas with polyatomic ions? Use it just like we did with the binary compounds. We use the Cris-Cross rule. You determine what ions are in the compound, and from the periodic table and ion chart, you get their charge. You put the metal first, then the anion with their charges, and apply the Cris-Cross rule. Then you reduce to the lowest whole number ratio, the ratio of one ion to the other. Our example compound is sodium sulfate. We have the sodium ion and the sulfate ion. The chart tells us that sodium is +1 and sulfate is -2. You probably memorized that already. So we put the sodium here with a +1, the sulfate here with a -2. We crisscross. The sodium's +1 down to here is 1. We change the sign on the sulfate, and we bring it down here, and that's the lowest ratio we can get in whole numbers, Na2SO4. Now, this is not Na2SO4, it is Na2SO4. The sulfate stands on its own, and if you dissolve this in water, the sulfate will go off on its own. The two sodium ions will go off on their own. So, practice. Write the formula for aluminum nitrate. Determine what ions are in there. Determine the charge on the ions. Metal goes first, then the anion, and make sure their charges are up on top. Apply the Cris-Cross rule and reduce to the lowest whole number ratio. And for aluminum nitrate, you'll find that's not necessary. Here's your ions. Aluminum is 3+, the nitrate is -1. We write those down. We apply the Cris-Cross rule, 3 down here and 1 here. Oh, what is this? NO3,3? Well, we're going to reduce it and add parentheses to tell us that the nitrate, all the nitrate, is tripled. We have 3 nitrates, not 9 oxygens, and 1 nitrogen. So AlNO3 taken 3 times, that's the way we say it. AlNO3 taken 3 times.